passing of this planet Nibiru, the actual home world of the gods.
We have nothing like it in the solar system, so it's new for us.
Only 5 planets were known for centuries until Sir William Herschel spotted the distant, icy blue Uranus in the late 1700s, mistaking it for a star. This discovery expanded our cosmic map, placing Uranus 19 times farther from the Sun than Earth. As astronomers noted odd movements in its orbit, suspicions grew.
This number 12 permeates through all the ancient cultures: the 12 disciples of Jesus, the 12 tribes of Israel, the 12 Greek Olympians.
Could a hidden planet be lurking in our solar system? Join us as we explore the alien planet that is hiding from humanity. From myth to reality, the 6th planet from the Sun. Herschel's curiosity didn't stop there. He also discovered double stars and nebulae. By the mid-19th century, scientists noticed that Uranus had strange tugs in its orbit. They thought another planet might be affecting it. In 1846, using precise calculations and telescopes, they found Neptune. Neptune is so far from the Sun that we can't see it with the naked eye. In the same century, Mercury's orbit showed strange behaviors that couldn't be explained by the theories at the time. A brilliant French scientist named Urbain Le Verrier suggested another planet might be influencing Mercury. He named this hypothetical planet Vulcan, after the Roman god of fire, thinking it was located between Mercury and the Sun. However, he never confirmed its existence. During solar eclipses, when the moon blocked the sun's bright light, astronomers searched for Vulcan. Despite many claimed sightings, no solid evidence was ever found. The theory persisted until Albert Einstein introduced his theory of general relativity. Einstein's theory explained that massive objects like the Sun could warp space and time, affecting how planets move. Even though Einstein offered a better explanation for Mercury's strange orbit, the idea of Vulcan stuck around for a while. Gradually, more observations and eclipses supported Einstein's theory over the Vulcan hypothesis. In more recent times, the idea of hidden planets in our solar system has continued. Scientists now hypothesize about Planet 9, or Planet X, based on computer models. They believe this planet might be far beyond Neptune, possibly as big as 10 Earths, and it could take between 10,000 and 20,000 Earth years to orbit the Sun. Another idea involved the mythical planet Nibiru, which some people claimed would collide with Earth in 2012 and end all life. These claims started in the 1970s from a book by Zecharia Sitchin, but had no scientific proof. As expected, Nibiru didn't show up during the predicted apocalypse. Before jumping to conclusions, it's important to understand that the researchers suggesting the existence of Planet 9 aren't just guessing. They've used advanced math and computer models to predict its characteristics. Their goal is to explain some strange behaviors observed beyond Neptune, especially in the Kuiper Belt. This vast donut-shaped region is filled with icy debris left over from the formation of our solar system, including comets and dwarf planets like Pluto. Interestingly, the 6 most distant objects in the Kuiper Belt have similarly shaped elliptical orbits, all aligned in the same direction and tilted about 30 degrees from the plane where our 8 known planets orbit. This odd alignment, which is highly unlikely to happen by chance, about 0.07% probability, suggests that something unseen is influencing them. This brings us to Planet 9, a hypothetical giant planet thought to have enough gravitational pull to affect these orbits. At first, this idea was criticized because of possible observational errors. However, a 2017 study renewed interest. Spanish astronomers used a new approach, focusing on extreme trans-Neptunian objects that have long, stretched orbits far beyond Neptune. They suggested that the points where these objects' orbits cross the plane of the solar system might provide clues to find Planet 9. These crossing points, or nodes, are important because they mark where an object's path intersects the solar system's plane. At these nodes, interactions with other bodies in the solar system are more likely, possibly changing their orbits or causing collisions. The stability of these orbits might hint at a large unseen planet affecting their paths. This research suggested such a disturbance, implying a planet might be 300 to 400 times farther from the Sun than Earth. But this wasn't the worst part. This ongoing study of extreme trans-Neptunian objects currently offers the strongest evidence for Planet 9's existence. If this sounds familiar, it's because similar methods led to Neptune's discovery after astronomers noticed oddities in Uranus's orbit. A hidden planet's gravitational pull explained these discrepancies, leading to the discovery of Neptune. In 2021, interest in Planet 9 grew again. New studies suggested this mysterious planet could take 7,000 years to orbit the Sun, meaning it might be closer and easier to observe than previously thought. Moreover, the probability that the strange orbits of these distant objects are due to Planet 9 is now seen as 99%, a significant increase from earlier estimates. These exciting developments have led to more observational efforts, including in Hawaii, where researchers have used data from the Panoramic Survey Telescope and Rapid Response System to rule out 78% of potential locations for Planet 9. Finding such a distant body is challenging, like finding a planet-sized needle in a cosmic haystack, but scientists remain hopeful. Looking forward, the Vera Rubin Observatory in Chile, set to start in late 2025, is generating a lot of excitement. Over 10 years, this observatory will scan the southern sky every few nights with a powerful telescope equipped with the world's largest digital camera. Its mission is to catalog celestial bodies beyond Neptune's orbit, including space debris, asteroids, comets, and stars. If Planet 9 is out there, this next-generation telescope has a good chance of finding it. But this wasn't the end of the debate. Despite the strong evidence, Planet 9's existence is still hotly debated among scientists. Some think the observed orbital anomalies could be due to the combined influence of distant objects like dwarf planets and comets, or even a black hole. Others suggest we might need to rethink our understanding of gravity, proposing that the movements of these distant objects might be influenced by the Milky Way's gravity rather than a single planet. As the search for Planet 9 continues, some astronomers propose even bolder ideas, like a hypothetical Planet 10. This planet, possibly as small as Mars or Earth, might be on the edge of the Kuiper Belt. However, if it's as small as predicted, it might not have enough gravitational influence to clear its orbit of debris, similar to why Pluto was reclassified in 2006. Meanwhile, our quest for space knowledge goes beyond just these hypothetical planets. On August 23, 2023, India's Chandrayaan-3 mission made a historic landing at the lunar South Pole, an area hidden from Earth's view and rich in lunar ice. This discovery excites scientists about the potential for a permanent lunar base or further missions to Mars, showing the endless possibilities of space exploration. Now let's explore some unusual activities in a faraway galaxy: black holes and galactic jets. Let's go back in time to an event from 45 years ago. A group of scientists spotted something strange in a galaxy located 9 billion light-years from Earth. We'll call this galaxy the Super Far Away Galaxy to keep it simple. You might wonder how scientists could study a black hole so far away, especially since black holes don't give off light. Here's how. Black holes pull in gas around them, and sometimes this gas shoots out into space. These jets of gas can be seen even from millions of light-years away. When these jets point towards Earth, the black holes are called blazars. One such blazar, which we'll call Andy, has been getting a lot of attention from scientists around the world. Imagine being a scientist at Caltech, looking through a radio telescope and seeing Andy's brightness change regularly, like a ticking clock. At first, this seems puzzling. After some study, you realize that another black hole, which we'll call Goomer, is orbiting Andy. Their regular twinkling suggests they might soon collide. Each of these blazars is hundreds of millions of times heavier than our Sun. To give you an idea, our Sun is already about 333,000 times heavier than Earth. If Andy and Goomer collide, they could create massive gravitational waves that might reach our solar system. This force could briefly stop the Sun's gas emissions, causing a sudden and short freeze on a summer day. A chilling thought, right? But that's not the worst part. In the worst-case scenario, the blast could be so powerful that it disintegrates all matter. People, animals, and objects could turn into dust scattered in space. While this is scary, it's also fascinating to remember that each atom is mostly empty space. We are all mostly nothingness, held together by forces we don't fully understand. Additionally, such a collision could change the fabric of space and time itself, altering how we perceive both. Einstein's theory of relativity taught us that time and gravity are linked and that time isn't the same everywhere in the universe. It changes depending on your location and speed. A collision between Andy and Goomer could warp our experience of time and space due to the intense gravitational forces involved. This might sound like something out of a science fiction movie. Remember the scene in Interstellar where a black hole allows the main character to bend space and time? While it seems dramatic, entering a black hole is not recommended. There's no guarantee of coming back. And here's a twist. These events between Andy and Goomer probably already happened because they are so far away. The collision likely occurred long before our solar system existed, about 9 billion light years ago. The light and effects from this event are still traveling towards us and will reach Earth in about 10,000 years. So this isn't something our descendants will witness for many generations. But here's something curious. Have you ever thought about octopuses and their otherworldly appearance? There's a theory that octopus eggs, preserved in ice on space rocks, might have crashed into Earth. This theory, similar to the ancient Greek idea of panspermia, suggests life is spread throughout the universe, carried by meteorites and space dust. While it's a fascinating idea, it's highly speculative and doesn't significantly advance our search for extraterrestrial life. But it does add a bit of intrigue to how we understand life's origins. Octopuses are amazing and ancient creatures. The oldest octopus fossil is nearly 300 million years old, which means they were around before the dinosaurs. These creatures are unique because 2/3 of their neurons are in their arms, not their brains. This means an octopus can use its arms to open shellfish while its brain does other things, showing off its ability to multitask. But this isn't the only impressive thing about octopuses. They're as smart as chimpanzees and dolphins, who use tools. Octopuses use shells to protect themselves, making makeshift shelters. While humans often think they're the smartest animals, we sometimes overlook others, like pigs. Pigs can play video games with joysticks, pushing a ball against a wall to get treats, proving they are pretty smart too. Pigeons are another example of surprising intelligence. In experiments, they could tell the difference between paintings by Picasso and Monet. They could even recognize new paintings by these artists. Though often seen as simple city birds, pigeons have a talent for recognizing art. Speaking of surprising talents, the red kangaroo uses its tail as a fifth limb to help it move. This adaptation not only shows their physical uniqueness, but also an impressive evolutionary trait for getting around. Australia is full of unique wildlife. The inland taipan, the most venomous snake in the world, lives there and can kill 100 people with one bite. Near Sydney, you can find the funnel web spider, another very venomous creature. But the worst part is the surprising creatures of the deep sea. The anglerfish, with its glowing lure, tricks prey into coming close enough to catch. Scientists only recently understood this fish's adaptation to its dark environment when they saw them living upside down near the ocean floor, using their light to find food in the deep sea's darkness. In the Sahara Desert, the fennec fox survives with its large ears, which help it cool down and find prey under the sand. In the Himalayas, the red panda, which is more like a raccoon than a panda, lives in the forest canopies. They huddle together for warmth and sometimes eat bamboo. Bees, even with their tiny brains, do complex tasks. They can get energy boosts from their hive mates without returning to the hive. This shows a high level of organization and resource sharing. In space, black holes are both fascinating and scary. They are regions of space where nothing can escape, not even light. Black holes come in different sizes, from just a few miles across to ones that are billions of times the mass of our sun. The smallest black holes are made when massive stars collapse, causing a supernova explosion and leaving behind a singularity surrounded by an event horizon. But don't worry, the chances of our sun encountering a black hole are incredibly low, making it almost impossible. So our solar system is safe from such a disaster for now. Next, imagine what would happen if a black hole came close to our sun. The sun's encounter with a black hole. Imagine if our whole solar system could fit inside the sun with space to spare. The sun contains almost all the mass in our solar system, so it's surprising that a tiny black hole, much smaller than the sun, could potentially swallow it up. But the truth is, it won't completely consume the sun. Now think about a rogue black hole wandering into our solar system, getting closer to the sun. As it approaches, the black hole's strong gravity starts pulling at the sun's surface. This pull stretches and distorts the sun, a process called spaghettification, similar to stretching a rubber band until it snaps. The stolen material forms a spinning ring around the black hole, known as an accretion disk. As this disk gathers more of the sun's material, it heats up and glows brightly with intense radiation. But this isn't the worst part. As the sun loses its material, It flares up, emitting huge amounts of light and heat, becoming even brighter and hotter. The sun's outer layers evaporate into a massive cloud of gas and dust, expanding outward like cosmic fireworks. This sight would be one of the most breathtaking views in the universe, but it would be invisible to us on Earth. The radiation and debris from this event would cause chaos on Earth. Wildfires would ignite, oceans would boil, and the atmosphere would fill with high-energy particles. The chances of any life surviving this catastrophe are almost zero. This disaster would not only affect Earth, but would destroy everything in the solar system. Despite the sun being larger than most stars, it would suffer greatly from this encounter. The black hole's gravity would strip away the sun's outer layers, causing a massive eruption known as a tidal disruption event. Eventually, the black hole would come out on top, growing larger and forming a new accretion disk. This clash between the sun and a black hole would be a huge and devastating event. But the good news is, the chances of such a collision are extremely low. However, we shouldn't stop studying black holes and their effects on the universe. The more we learn about these cosmic phenomena, the better we can predict their behaviors. Let's keep exploring the mysteries of space, and maybe one day, we'll encounter a black hole that gets too close to the sun. By then, hopefully, humanity will have settled on distant planets. The universe is vast and always changing. Just like we have baby photos to remember our early days, scientists have captured the universe's baby photo, looking 14 billion years into the past. This achievement, like winning the Oscars of science, was made possible by NASA's Wilkinson Microwave Anisotropy probe. This satellite collected data that has answered many big cosmic questions while also raising new ones. This image, known as the Cosmic Microwave Background, CMB, is not a photo in the usual sense. It shows a faint glow filling the universe, giving us clues about its early days. When seen with special radio telescopes, the space between stars and galaxies, which looks dark to us, is revealed to have a faint, even glow. This glow, the CMB, is strongest in the microwave part of the spectrum and is a remnant from a time when the universe was a hot, dense fog. At first, the universe was so hot that atoms couldn't form and light was scattered by free electrons. But as the universe expanded and cooled, electrons and protons joined to form hydrogen atoms, making the universe transparent. This moment, known as the recombination epoch, allowed light to travel freely for the first time. The CMB we see today is that ancient light stretched into microwaves by the expanding universe. It's the oldest light we can see, a snapshot from when the universe first became clear. As this light traveled through the cosmos, passing stars and galaxies, it changed, giving us clues about the universe's structure and content. Studying the CMB has shown that only about 5% of the universe is made of normal matter. The rest is dark matter and dark energy, invisible components that make up most of the cosmos. This research has painted a picture of a universe that began smaller than a proton, governed by quantum mechanics, and rapidly expanded during a period of cosmic inflation. This cosmic expansion created gravitational waves, leaving unique patterns in the CMB, like cosmic fingerprints. By examining these patterns with tools like the Wilkinson Microwave Anisotropy probe, scientists continue to uncover details about the early universe, from its expansion to its overall shape. This ongoing investigation helps us understand the profound mysteries of our origins and the nature of the universe itself. What if understanding dark matter and dark energy could redefine physics? Share your thoughts, like, and subscribe for more.